Here we have another example where you're given some information about the graph of a parabola and you're asked to do two things. Find the equation, plot the graph. Okay, so we're going to start again. I always try to plot these things, just what's given. I guess I'm kind of a visual person. I like to see what's there, and then it helps me to determine the orientation of the graph and the location of any missing information. Okay, so first I would plot the vertex is at 2, -3. So I've got a grid set up here. I've got 16 units in each direction, each axis. I don't know if that's going to necessarily be sufficient. It probably is overkill, but we'll try it. So 2, -3 is over 2 and down 3. So that's going to be our vertex. And then the directrix is down at -7.5 in the y direction, right? Y equals -7.5. Remember, y equals are going to be horizontal lines. And so I go down to -7.5. That's right about here. It's between 7 and 8. -7, -8, and draw that in horizontally, or as close to horizontal as I can make it. All right, not too bad. And we'll label that as D for the directrix. The next thing I want to find is the focus. Now the focus is an equal distance away from the vertex as the directrix, but in the opposite direction. So if you think about the vertex to directrix being this vertical distance here, then the focus is going to be the same distance above the vertex. So we're obviously looking at y values here. Okay, drop that just a smidge. And so the y value on the directrix is -7.5, and if I subtract the y value from the vertex, that's going to give me the distance between them, which in this case, -7.5 plus 3, when I get the double negative taken care of, that's going to be -4.5. Okay, so this distance is, well, it's 4.5. It's -4.5 down. Distance is positive, obviously, and so I need to go 4.5 units up. Okay, distance technically would have an absolute value on it. I'm not worried about that right now. I just need the idea, the general idea. So I need to go 4.5 units up. So from -3, if I were to add 4.5 to the -3, that would get us the positive direction there. And that gets us a value of 1.5. So the focus must be located 1.5 units upward, but at the same x value as the vertex. Okay, so that would tell me my focus is actually at the coordinates 2, 1.5. Again, same x value as the vertex, and then this new y value is what we're looking for. Okay, so 1.5 units up. That's pretty close. We'll call that the focus right there. Okay, so I've got my three of my key pieces of information. The other two that are very important are the two ends of the latus rectum, which are across from the focus. I also need to know the orientation of this graph, and it is opening upward. Okay. Because it has to surround that F. And so the equation I want to use is going to have a square on the y and a linear x. Sorry, I did that wrong. A square on the x and a linear y. Oops. So you want to surround the y-axis. That's going to be your linear. So it's going to be an x squared equals 4ay. That's sort of the base structure of this equation. However, this is shifted, right? The vertex is not at the origin, it's shifted. And so I actually need to adjust that to an x minus h squared equals 4a times y minus k, where h and k are the two values from the vertex. Okay, those are our shifts. And it is opening upward, so a positive coefficient here for the A value is appropriate. And so now I need to find the A value. We actually already did find the A value. The A value is this negative 4.5. That's the distance between the vertex and directrix or the vertex and focus, either one. All right, of course, it's positive. We just said it has to be positive to open up. So all of the signs on these things are just based upon what direction the graph goes. Okay, and then finally, I just need to plug that stuff in. So I plug in the H is 2, the K is -3, and the A is 4.5, and that should give me the full equation. So it's x minus 2 squared equals, 4 times 4.5. 4 times 4 is 16, 4 times a half is 2, 16 and 2 is 18. So it'd be 18 y, now minus -3, double negative makes a +3. So that gives us the structure and the actual equation then for the parabola. I'm not quite done because I still have to graph this thing. And remember that the latus rectum, L-A-T-I-S, right? The latus rectum is 4A units across. That means from the focus, I need to go 2A in both directions, plus 2A minus 2A. And so in our case, the A value is 4.5, so that means I need to go 9 in each direction, okay? Let's see. So if I go to the right 9 units from the focus, starting at 2, going right 9, that puts us at 11. So it'd be 11, comma 1.5. Let's see, where should I write that? I'm down here. 11, comma 1.5 is one end of the latus rectum. And the other end is going to be 9 in the other direction. Well, if I start at 2 and go 9 to the left, that puts us at -7 and up 1.5. So -7, comma 1.5 will be the other end. And yeah, that's pretty good. So the other thing I would like to plot is the axis of symmetry. I didn't put that on the last example because the axis of symmetry was right on the x-axis and we didn't have to worry about it. But here, the axis of symmetry is shifted over, and so I would plot that right here vertically along the x equals 2 line. In fact, I might label that axis of symmetry is x equals 2. All right, and then I can plot the graph going from the vertex through the ends of the latus rectum. I kind of missed that one, but you kind of get the point. I don't know. There, that's not terrible. Good enough. That'll work. Okay, so that's the parabola. It gives us the graph with all the details, right? It's got both ends of the latus rectum. It's got the directrix, focus, vertex, axis of symmetry, everything we really need to be able to describe that line. A couple things I don't have on here are the x and y intercepts, which we could find. The x and y intercepts could always be found just by plugging 0 into the opposite variable in this equation. You could algebraically find those if you needed them. I would leave that up to you guys to do that. But again, to find the y-intercept, you put an x in you put a 0 in for x and solve for y. And if you want to find the x-intercept, you put the 0 in for y and solve for x. Those are doable. Other than that, that's all the other bits of information we might need.